Hello friends, welcome back to our channel. So today we'll see one more session in files. So that is file allocation methods. So in our previous session we have seen what is a file, different types of files, different types of file systems, and also we have seen the file accessing methods. So in today's session let us see the one more concept in files, that is file allocation methods. So we know that a file is a collection of related data which is stored in a hard disk. So here the question is how the files are being stored in a hard disk, so that the disk efficiency should be there, right? So the memory management, right? And also accessing should be fast. So we are storing the files in the hard disk, and whenever we want to access the data from the file, that accessing should be fast. So in order to maintain these two things, that means a disk utilization, okay, storage utilization, as well as access time, fast access time. So how many ways we can allocate the disk blocks to a file? So a file is divided into different blocks, and the file will be stored in different blocks of a hard disk. So that concept we'll see in today's session. So let us start. File allocation method. So it defines how the files are being allocated in hard disk or storage. So we need not call it as a hard disk, we can call it as a storage. So usually the files will be stored in the secondary storage. So how these files will be allocated? So there are three ways how the files can be allocated. First one is a contiguous file allocation. Another one is a linked file allocation. Another one is a indexed file allocation. Okay, indexed file allocation. So initially we have to know that the secondary storage will be having a lot of disk blocks. Okay, a lot of disk blocks. So among that disk blocks, how this file can be allocated? So file will be divided, and each portion of the file will be allocated to each disk block. So let us start with the first one, that is a contiguous. Contiguous. So let us take the hard disk. So let us assume this is a hard disk, and this hard disk will be having a different disk blocks. So let us assume these are the disk blocks of a hard disk. These are different disk blocks. So in these disk blocks we have to allocate the files. How many ways we can allocate? So this is a hard disk for a storage. Okay, storage. So each disk block will be having the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So these are the numbering given for the disk blocks, right? Now each file will be allocated to these disk blocks. As the name itself indicates, this contiguous. So a file is allocated to a continuous disk blocks. Continuous disk blocks. Okay. So the complete file will be allocated in a continuous disk blocks here. And here it will maintain some file allocation table. So file allocation table. And this table consists of directory entries. Okay, directory entries. So directory entries means the information related to the file. Okay, and this directory entries will be having the three fields. One is a file name, another one is a start block, so from where it starts, and the next one is the length of that particular block, length of that particular file, sorry. So these are the three fields that are used in file allocation table. So as we are saying, the file will be allocated to continuous disk blocks, right? So for example, a file size is some 15 KB, okay, and disk block size is around 5 KB, and if the file starts at disk block 4, then automatically the remaining blocks will be at 4, 5 and 6. So these are the disk block numbers where the file will be allocated, because each block consists of 5 KB. So total file size is 15 KB. So continuous blocks only the file will be allocated. Okay. For example, if it is of 18 KB, then 4, 5, 6 and also 7. So the file will be allocated in this way. So what happens? This is a 5 KB, this is a 5 KB, this is a 5 KB, and this is a 3 KB data will be stored. What about the remaining 2 KB? So there is a memory wastage. So that we are calling it as an internal fragmentation. So that is one drawback of this contiguous memory, contiguous file allocation. That is a internal fragmentation, right? So it allocates, so one concept is it allocates the file in a continuous disk blocks, only in the continuous disk blocks. For example, let us consider this disk space. This is a hard disk. So here the file name, some A is a file name, so which starts at 1 and the length is 2. So that means here this is a, okay, and the length is 2. That means only 2 disk blocks. That is also contiguous. After 1, the second block. So these 2 blocks will be storing file A. So this is of file A. And similarly, if it is B, and if it starts with a 4 and if the length is 5, so it starts with a 4, okay, and the length is 5, so 5 blocks, 5 contiguous blocks. See, these are the contiguous blocks. So 1, 2, 3, 4, 5. So this is a B. The file B will be stored in 5 contiguous blocks. 5 contiguous blocks. Okay, so this is how the contiguous file allocation will be done. So one point, the file will be allocated to continuous disk blocks, and the file allocation table will be maintained, and this file allocation table will be having the directory entries of all the files. So one is a file name and where it starts and what is the length of that file. Now what are the advantages? So advantages of using this file allocation is very simple to implement, because it is contiguous, simple to implement. It is simple to implement, as well as sequential access will be supported. Okay, so we have seen file accessing methods. In that accessing methods we have seen sequential, direct and indexed. So sequential access will be supported. Sequential access, so that means data by data, line by line, or the sequential form, right? And what about the disadvantages? What about the disadvantages? The one disadvantage is, for very large files, it is difficult to find out the contiguous memory blocks. For example, if the file size is some 100 KB, okay, and disk block size is, let it be, so 5 KB. So how many blocks required to allocate this file means 20 blocks. So all the 20 blocks should be in a contiguous manner. So it is difficult to find a large number of contiguous blocks, okay, in order to store a large files. That is a main disadvantage. So coming to the large files, allocation is difficult. Large files allocation will be difficult, and similarly internal and external fragmentation also there. Internal and external fragmentation is also there. So what is the internal fragmentation? Just now we have seen, for example, if you consider this B, So B is of some around yes 21 KB. Okay, 21 KB. See here, I'll tell you 21 KB, and this block is 5. So how many blocks it requires? 4 blocks. If you take 4 blocks, it can accommodate only up to 20 KB. So now we have to take the one more block, which is a fifth block. So in the fifth block, how much KB, how much data will be stored? Only 1 KB of data will be stored. What about the remaining 4 KB? That is a wastage. So that is called as a internal fragmentation. Internal fragmentation. For example, if you consider C, okay, if you consider C, and I'll write here, if you consider the file C, okay, C is of capacity, for example, 17, okay, 17. How many blocks are required? So disk block size, for example, disk block size is 5. How many number of blocks it requires? Some 4 blocks of memory will be required, right? So all the 4 blocks should be in a contiguous. But here you can see this one is available, this one is available, this one available, and this is also available, but there is no contiguous. Okay, there is no contiguous. So total how much memory is available? 5 plus 5, 10, 15, 20, 25. So 25 KB of data can be stored in the hard disk, but we can't store the file C in this one because file C is having only 17 KB, which have to be accommodated in a contiguous blocks in this particular file allocation method. So this is called as an external fragmentation. Internal fragmentation and external fragmentation is also difficult. And file size problem, one more problem, file size problem. So what is this file size problem? If the file is being increased, okay, the data is increased and the file size is increased, and it is difficult to accommodate the new block. So because it is a contiguous, so in order to find the continuous block, that will be difficult. So this is also one disadvantage of this kind of contiguous file allocation method. So in order to overcome all these disadvantages, we are moving on towards the second one, that is a linked um, file allocation method. So let us see what is a linked file allocation method, what happens in that. Okay. Linked file allocation method. So these are the disks as just we have seen. So these are the disks, just give the number. Yes. So in this link, it is not necessary to store the complete file in a contiguous. So data is not, so instead of data we'll write a file. Okay, file is not stored in contiguous blocks. So in order to link up the blocks, every block will have a pointer which points towards next block, which point towards the next block. So here one pointer will be given for each and every block, and that pointer will be pointing towards the next block. So that is why we are not storing the file in a contiguous blocks. And see, pointer in last block points to null. Okay, points to null in order to say that is a last file. Okay, last block. So here also there is a file allocation table. In the file allocation table, it will give the three terms. One is a file name, start and end. So let it be file A. It starts at some 2 and it ends at some 7. So it starts at 2. Okay. So the pointer at this 2 will be pointing towards the next block. So whatever the next block, right? So the next block is 6, for example. Okay. So let us write here A, file A. It starts with a 2. So the next one is links to 6, where it links to 11 and which links to 7. So that means A requires some 4 blocks and that 4 blocks are not necessary to be a contiguous. So one block, the pointer at one block will be pointing towards the next block. So first starting with the 2, the pointer in 2 will be pointing towards the next block. So next block is 6. So the pointer in 6 will be pointing towards the next block, which is 11. So 11 points, the pointer at 11 links with the block 7. So the three fields, one is a file name, start and end. Okay, and the, for example, second one, the B, so it will start at some 10 and the last one maybe it is 1, right? So it starts with 10, the pointer at 10 will be pointing towards another one, the next block, so which is a 5 and 5 points to 1, for example, 5 points to 1. Okay, so this is how the allocation will be done. So where it need not require any contiguous memory location. So there is no external fragmentation. Here there is no external fragmentation, right? So here the advantage is no external fragmentation. No external fragmentation, because so the blocks need not be in a contiguous manner, right? And also the file size problem is also removed, because if the file is increased, then automatically wherever the file block is empty, the file can be accessed to that particular empty block. So no file size problem. There is no file size problem. Okay, and drawback, no direct access. So if one process, I mean, if we want to access a block 7 directly, it is not possible. So it have to access from 2 to 6, 6 to 11 and 11 to 7. It is a sequential, there is no direct. Okay, that's a one problem. And the next problem is every block contains a pointer, so where some memory should be allocated for that pointer. So obviously pointer overhead is also there. Pointer overhead. Okay, so hope you understood. Every block will be having a pointer, we are saying, which points towards the next block. So every block should leave some memory to store this pointer. So memory, some sort of memory will be wasted, or we can also say it as a pointer overhead. That is a problem. Okay, and in order to overcome all these things, mainly the direct access, there is no direct access in this particular method. So we are moving on towards the third method, that is called indexed. See, yes. So coming to the indexed, what happens in this indexed? In this indexed, every file will be having indexed block, one indexed block. Okay, every file will be having one indexed block. Okay, so what will be there in this indexed block? So this indexed block, it stores addresses of all blocks of a file. So if a file consists of some 5 blocks, it will store the addresses of all the 5 blocks. It will store the address of 5 blocks. For example, see, this also contains the file allocation table. So where we are having only 2 columns, which is a file name. Okay, file name. So the indexed block. Okay, this then indexed block. Only 2 files, file name and indexed block. For example, so 7 is an indexed block. Okay, 7 is an indexed block, and all the related blocks, I mean the block 7 will be having the addresses of all blocks of this particular file. So for example, the file has been stored at 8 2 sorry, let us go with an order: 1 3 6 8 and 12. So if the file is stored in a 5 blocks, and the address of all these 5 blocks will be stored in indexed block called 7. In order to avoid confusion, let us take this one: file. If a file stored in these blocks, so address of all these blocks will be stored in address. So this is called as an indexed block. Okay, so this block number will be displayed in the file allocation table. For example, file A. So file A, so which is having the indexed block, which is a 7. Okay, 7. So 7, from here there will be location 1 3 6 8 12. So these are all the files, the blocks which stores the file. Okay, so file A is stored in a 5 blocks. File A is stored in a 5 different blocks. So all the addresses of all 5 blocks will be stored in one block, which is a indexed block, which is called as an indexed block. So here 7, so which can be having 1 3 6 8 and 12. So what is the advantage of this one is direct access. So we did not perform the sequential access. If you want to access some data which is at 12, directly we can access the block 12. So we need not go process with the 1 3 6 8 12, because 12th address will also be available in the 7th block. Okay, direct access will be there. Okay, and also no external fragmentation. No external fragmentation. This is also advantage. No external fragmentation. Coming to the disadvantage. So what is the disadvantage of this one is, so this is automatically it's a pointer overhead or indexed overhead, because so it contains a lot of indexes. There will be an index overhead. Okay, and also we are storing one file dedicatedly as an indexed block, so there will be some sort of memory. If it is a very less if the file size is less, automatically one block will be wasted for storing the address of that particular file. Okay, and also if you lost this indexed block, automatically the file can't be accessed. Okay, so if indexed block is lost, file will be lost. Okay, if indexed block is lost, automatically we can't access the file, because the complete address of all the blocks of a particular file will be stored in the indexed block itself. Okay, so this happens here. So these are the some advantages and disadvantages, but direct access can be done in this indexed file allocation method, right? So hope you understood. We have seen how the files are being allocated in the disk space. Okay, the three ways: contiguous, linked, and indexed. And why we are using these many methods means in order to maintain the disk efficiency and also execution faster. Okay, fast access. Yes, so I'll stop here, and hope you enjoyed the session. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.